of this sine model, the sine model or the cosine model. A is the number in front of the sine function or the cosine function. So the amplitude is the absolute value of that number. And probably should put in here the distance from the midline to the high or low. And in the picture down here, you can see here's the midline. And so the distance from that midline to the high and the distance from the midline to the low is going to be A, the amplitude. It's not the total distance from the high to the low. It's actually half that distance. So if the total distance from the high to the low is 2, then the amplitude's 1. Or if you look at it the other way, if your amplitude is 4, then the total distance between high and low would be 8. It'd be double that. We went the other way. If the amplitude was 4, then the total distance between high and low would be 8.
What's that little thing that looks like I equals something cosine theta?
Y equals -1 cosine theta. And so the amplitude is the absolute value of -1, which is 1. Y equals 5 sine theta. So the amplitude is
5.
absolute value of 5, which is 5. Second one, y equals -2 sine theta. Amplitude is absolute value of -2, which is 2. It's important to understand amplitude represents distance, therefore we use absolute values. Amplitude is not automatically the number in front of the sine function. Okay? It's the absolute value of that number. Okay? Any questions? Moving on then. The period of a function. Y equals sine k theta. And y equals cosine k theta. The period is 2 pi divided by k, when k is a number greater than 0. So k can't be a negative number. Okay? And then below the line is an example. Let me pause. Remember, in lesson 6.3, you talked about the period of a sine function, the period of a cosine function, and it told you that the period was 2 pi. Meaning that in a sine function, the time it took to get from 0 to 1 to 0 to -1 back to 0 again to complete the entire cycle was 2 pi. At pi over 2, at 90 degrees, the value of sine is 1. At 180, it's back to 0. At 270, it's, or I should say 3 pi over 2, it's going to be -1. And at 2 pi, it's going to be 0 again, ready to start that cycle all over again. As you go around the unit circle, and you continue to go around and around and around, it just keeps cycling through this wave. Okay? Well, sometimes an equation changes that. And this number in the function that's in front of the theta, the variable, okay, this number affects the length of this cycle. Okay? It squeezes it together, it pulls it apart, it does all kinds of strange things. Somebody asked me a question last week, and my answer right away was wrong because I didn't look at the fact that they had taken this and stretched it out over 4 pi instead of 2 pi. I didn't read the scale on the x-axis, okay? And that's what's happening is that number in front of the theta is being changed. So here's an example. Looks like I already did it. The number in front of the theta is 2, so that's k. So the period is 2 pi over k, which is 2 pi over 2, which is pi. And so if I was graphing this, remember how I told you my graphs all look the same? I changed my scale to match my graph. If I was graphing this, I would call this, actually this is cosine. I probably can't grab it now. Cosine graph starts at 1, right? The value, the cosine of 0 is 1. And so that's the difference between sine and cosine is where it starts on the x-axis. So it would start here. And so if I move all of this over, okay. If I move all of this over, and then I finish this, starting here, okay? Let's erase it. All right, so here's my cosine graph. And so it starts at 1, goes to 0, goes to -1, goes to 0, goes back up to 1. It's ready to start over again. It'd be that same cycle over again. And so if my period is pi, then I would call this pi. And halfway through my cycle would be here, right? And so what do you think I would call that? Pi over 2, because that's half of pi. And so then here, half of that again, whoops here. Half of that again, that's what I was thinking about. Yeah. Let me just erase it. What's half of pi over 2? Pi over 4. So this is pi over 4. And so each unit then would be pi over 4. So if this is pi over 2, and I add pi over 4 to it, what do I get? 2 pi over 4, right? Pi over 2 is equal to 2 pi over 4. And one more pi over 4 would be 3 pi over 4, right? And so that's how I do it. Now I'm not saying you have to. You can make your scale exactly the same every time and make your graph match it. I just choose to go the other way because for me it's quicker and easier. I make my graph the same every time, then I make my scale match what the information in the equation tells me it has to be. Okay? And I might have to look at it twice, but I'm smart enough to figure out what you've done, especially on the test. If I ask you to graph on the test, I'll look at it carefully, I'll get it right. Okay? So understand that you have two options when they ask you to graph. So in this one here, it says y equals cosine theta over 2. We want to find the period. So what's the formula for period?
2 pi over k.
2 pi over k. What's the value of k in this case?
0.5.
Yeah, or as a fraction, 1 over
2.
2. So 2 pi over 1 over 2. Remember, dividing by a fraction, same as multiplying by the
Reciprocal.
reciprocal.
4 pi.
So 1 over 2 turns into 2 over 1 times 2 pi, which is 4 pi. So now, I take that same graph, but instead of labeling it pi here, I would have called this 4 pi. And halfway in the middle would have been 2 pi. And halfway between that and the beginning would have been
Pi.
1 pi. And then halfway between 2 pi and 4 pi would be
3 pi.
3 pi. My graph doesn't change, my scale does. Okay? Now, you have to understand, if you're looking at it on your calculator, their scale doesn't change, the graph does. So it's going to look different. Okay? But it's, either way is fine with me. Totally up to you. And the last one, sine of 3 pi over 2 theta. And so period is 2 pi over k. And what's k? 3 pi over 2. Sorry. 2 pi over 3 pi over 2. So if I flip that over, I get 2 pi times 2 over 3 pi. What happens to my pi's this time? They cancel, leaving me with 4 over 3. Okay? 4 over 3. Now, let me pull this graph down here, and I'll pull that back up. It's a sine graph. Yeah. We did all that for nothing. My sine graph looks like this. Okay? Starts at 0, goes to 1, goes to 0, goes to -1, goes to 1 again. There's a 0 again. And so, now I'm going to make my scale match. My period is 4/3. What is half of 4/3?
2 over 1.5.
What is half of 4/3?
It's just 2 over 3.
It's 2/3, right? 2/3 is half of 4/3. What is half of 2/3? 1/3. And here's the tricky part. It's not a third.
This is.
Yeah, it is too. It's 1. It's 3/3. Okay, sorry, I didn't look at it right. Okay? So we get 1. There's no pi on this scale, is there? How much is pi? 3.14. So this is 1, and pi is 3.14, so it would take 3 of these and a little bit more to get to where pi normally is, right? So this is really shrunk down. If I looked at it the other way, and I said this is pi, so say here's 3, 2, 1. All of this is happening in that much space. Okay? All of that's happening in about that much space. Yeah, go ahead.
You said we could change the scale, but do you want us to only carry it out to like 4 over 3 and not pi every time?
if you change the scale like I do, then you're never gonna worry about pi. You're gonna, whatever that number is, that's gonna be your,
And
the end of your cycle, your period. And then you're gonna have to cut it in half. Now here's the problem. Sometimes they say graph it from 0 to 2 pi. And so this is my cycle. And I've only gone to about a third of, a little more than a third of a pi, right? And so I'd have to carry this out to 2 pi. So I would go through the cycle a few times to get there. I'd have to copy this until I got out to about 2 pi.
yeah.
So in that case, either way, it's going to be the same in that case. I think it's easier to find your highs and lows and draw your graph like this. But because there's no pi in there, you have to realize that 2 pi is around 6.28, right?
Yeah.
And you're only at 1.3333, right? So you have to go until you get to 6.28. Okay? Good question. Number 4 says the amplitude of 9.8 in a period of 6 pi, and they want us, I think if you look at it, it says write the equation. Would someone read number 4 from your book? Again, we're looking at this model. It's y equals a cosine k theta. Okay? And so, you might want to think of it this way for later on when we add more to this equation. For now, this is all we're looking at. Amplitude is 9.8. So the amplitude is equal to 9.8. And so that means A could be a positive number or it could be a negative number. We don't know yet, do we? There will come a time when you'll have to make the call. But on this model, we're just saying what it could be. It could be either positive or negative. We aren't sure. Okay? And there actually will come a time when you have to decide, am I going to use sine or cosine? And I'll try to help you understand what to use when we get to that. The period was 6 pi. In the model, the defined period is 2 pi over k, so 2 pi over k is going to equal 6 pi. And so when we have a proportion like this and our unknowns in the bottom, what can we do? Switch places. So we get 2 pi over 6 pi equals k. And so k is equal to 1/3. So if we go back now, y is equal to, plus or minus, we don't know which, 9.8 cosine 1/3 theta, or you could write it as, and it's easier to write, it looks better, you write it as theta over 3. Okay? So that's our model. Questions on that? You notice the smaller this number, the bigger the period. The bigger that number, the smaller the period. Okay, that's because we're dividing 2 pi by whatever that number is. So if you divide a number by a really, really small number, it makes your number a lot bigger, doesn't it? If you divide a number by a half, it makes it twice as big, right? Divide it by a sixth, it's going to make it 6 times as big. Okay? Any questions on this? No. Frequency. is equal to 1 over period. They'll ask you about the frequency. All it is the reciprocal of the period. And the period is the reciprocal of the frequency. So period and frequency are reciprocals of each other. Frequency is always measured in hertz, which is cycles per second. How many cycles per second? That's frequency. Sound waves, sine waves, cosine waves, they all look the same. Okay? And so they're measured in hertz. I don't think we need to spend too much time on that. All you have to do is, you need to find the frequency, find the period, flip it over, you've got the frequency. Okay? We'll move on.
Is this the last? Nope. Yep.
What's the amplitude in this equation?
2.
Absolute value of 2, which is 2. And the period is
Pi.
2 pi over 2, which is pi. Okay? So, what I do, I would say this is pi. 4 marks out. Remember, we go from 0, sine, so we go from 0 to 1, 1 to 0, that's another one, 0 to -1, and -1 back to 0 again. So we need 4 marks to get our entire cycle, and so I'm going to call that pi. Halfway in between is pi over 2. Halfway in between that is pi over 4. And so halfway between pi over 2 and pi would be 3 pi over 4. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And it starts at 0, goes up. Looks something like that. Oh, sorry, my bad. What did I ignore? No, I ignored the amplitude. It's 2. I think I didn't go down to 2. Let's try that one more time. I went up to 2, but I didn't go down to 2. 2 is down here. This is hard to draw with my finger creating shadow on the board, not seeing where I'm going. So anyway, it looks something like that. Okay? Any questions on that? Don't forget the amplitude like I did. Amplitude is the distance from the midline to the high and from the midline to the low. That's amplitude. Okay? All right. You have your assignment. Pull that back up so you can see it.
We're gonna do this?
1735 odds.